students. This is your facilitator, Dr. Danish here, and today we're going to discuss the importance of dietary carbohydrates and glycemic index. Now, before starting this important topic, what you need to understand here is that this not only going to help you in passing your semester exam, but it also help in your professional life as well. You will today from today's discussion you will understand that what the dietary components are carbohydrate, what carbohydrates are actually are, and what their importance is in the diet, and how they contribute uh, in any disease. And you're also going to understand the glycemic index. That's the most important thing as far as the management of diabetes mellitus is concerned. You will know the foods that are low glycemic index, that have um, and that have high glycemic index. Now, the learning objectives for today's discussion is to identify the basic food sources of the major carbohydrates, the monosaccharides, disaccharides, polysaccharides, and fiber. What are these, and in which food item these mono, di, and polysaccharides are actually present? Then, at the end of the lecture, you'll be able to list the functions of carbohydrates in the body, describe the regulation of blood glucose, how the blood glucose is being regulated, and which factors contribute in increasing the blood glucose and which factors contribute in decreasing the blood glucose. Outline the beneficial effects of fibers on the body, that fiber is really important as far as health is concerned. So you will be able to uh, you will be outlining the beneficial effects of fiber on the body. Then you will be able to state the recommended dietary allowance for carbohydrate, how much carbohydrate should be taken in a diet per day, and explain the glycemic index and glycemic load at the end. So these are some of the learning objectives we'll be discussing today. Now, to start with, the balanced human diet includes all the major macromolecules, the proteins, carbohydrate, fats, and the micronutrients like minerals and vitamins. Now, as we are going to discuss carbohydrates, we'll be discussing what are the major components of carbohydrates and which food item contains these carbohydrates. Now, approximately a normal adult who weighs approximately 70 kilograms, he requires approximately 2200 kilocalories, out of which approximately 50 to 55% of his normal diet should contain carbohydrates. That comes from the food item that contains carbohydrates. Then 30% should be from the fat, and 50 to 20% from the proteins. This is basically a recommended proportion of energy supply, that the proportion of carbohydrate in your diet should be approximately 50 to 55% in a normal condition. The sources of carbohydrates, we can classify the sources of carbohydrates into mono, di, and polysaccharides. Polysaccharides are also known as complex carbohydrates. The complex carbohydrates are basically starch and glycogen. The monosaccharides we have is glucose, fructose, and galactose. We get monosaccharide and glucose, fructose, and galactose from various food items. And then we have disaccharides like maltose, lactose, and sucrose. As from your previous knowledge, you will be recognizing that maltose is basically a disaccharide that is made up of two glucose residues. Lactose is a disaccharide which is actually present in milk and contains two monosaccharide residues, that is glucose and galactose. Then we have sucrose, which comes from the table sugar, and so again is a disaccharide that is made up of a glucose and a fructose. Then we have a polysaccharide, that is We can have amylose, amylopectin, glycogen, and starch. Glycogen, starch. These are the complex carbohydrates which are usually present in our normal diet constituents. Now, a general function of the carbohydrate. Uh, a carbohydrate, it can provide loads and loads of energy. A carbohydrate, most of the carbohydrates, all the polysaccharides, all other monosaccharides like fructose, galactose, they all are converted into glucose, and then glucose goes into a metabolism pathway, a metabolic pathway, that is glycolysis, in which the glucose is being broken down, and then it forms pyruvate, and the pyruvate goes further into the TCA cycle by forming an acetyl CoA, and then it is being uh, uh, it provides loads and loads of energy. So it provides energy. Approximately 1 mole of glucose synthesizes 38 moles of ATP. Now, if we see that how much carbohydrate actually, it actually synthesizes approximately 4 kilocalories of energy per gram of carbohydrate. The non-essential amino acids which are actually being synthesized, they can also synthesize carbohydrates within our body through their carbon skeleton. So they also basically they not only provide they not only synthesize carbohydrate, but can they can also be synthesized in the body as well. So the carbohydrates, the non-essential amino acids, they are synthesized from the carbon skeletons. And if you remember the structure of an amino acid, it has a central carbon to which on one side we have a carboxylic group, to the other side we have the amino group. So if you remove the amino group, which what is left behind is a carbon skeleton. That carbon skeleton is basically comes from the intermediate metabolites of glucose metabolism. That is intermediate metabolite, that is the metabolites of TCA cycle, the pyruvate itself. So they can easily be converted into essential amino acids by simply addition of the amino group. Then we have fat. The carbohydrates can synthesize fat via acetyl CoA. If we eat an excess of energy, the acetyl CoA, the excess of acetyl CoA will be synthesized. The TCA cycle will be overwhelmed, and instead of going into the TCA cycle, the acetyl CoA will synthesize fatty acids. The acetyl CoA from the mitochondria inside the mitochondria goes out of the mitochondria into the cytoplasm through a citrate shuttle, and then it synthesizes fatty acids. Carbohydrates, it can be stored in the form of glycogen, and the major storage site for glycogen is liver and muscles. So we have two types of glycogen storage sites. We can store glycogen in liver, and the other site is muscles. But what you need to remember here, that liver glycogen is the only glycogen that can maintains the blood glucose concentration, whereas the muscle glycogen is only meant for its own energy needs during muscular contractions, and it cannot maintain the blood glucose because the lack of the enzyme that is hexokinase. Um, I'm so sorry. The enzyme is glucose 6 phosphatase enzyme that breaks down the glucose 6 phosphate into glucose. So the enzyme deficient in muscle tissue is glucose 6 phosphatase enzyme. Then we have a TCA cycle intermediates, as we already talked about, that the non-essential amino acids which are being synthesized from the TCA cycle intermediates, they also are synthesized from the glucose residue, that is carbohydrates. Then in the sugar portion of the nucleotide, that is the ribose or deoxyribose sugars, they also are synthesized from these carbohydrates. Then we have glycoproteins, proteins binded with the carbohydrate residues, different carbohydrate residues that can bind with glucose, galactose, and they have diverse functions in the body. Then we have glycolipids again. Glycolipids, they also be synthesized by addition of carbohydrate to the lipid. So there are various functional carbohydrates. It can provide energy. It can synthesize amino acids. It can synthesize fat, glycogen, TC cycle intermediates, nucleotides. That is the building blocks of nucleic acids like RNA and DNA. Then the glycoproteins and glycolipids, they also are being synthesized from the carbohydrates. Now, when we see the overview of metabolism, as you can see here, we have the TCA cycle, the citric acid cycle, which breaks down the acetyl-CoA, a two-carbon compound. Acetyl-CoA enters into the TCA cycle and it forms the NADH, and then the NADH captures the chemical energy in the form of hydrogens for protons, and then these reducing equivalent like NADH and FADH carries the energy to the electron transport chain, and the electron transport chain accepts the protons and electrons, and then it forms the energy through the electron transport chain. Now, this acetyl-CoA is basically the common intermediate metabolite, which is being contributed not only by the carbohydrate, but also it is contributed by the amino acids and the fatty acids as well. As you can see here, the polysaccharide, which we normally take in our diet, the complex carbohydrates like starch, uh, which are actually present in our food items like rice, roti, chapati. So they are being broken down by digestion absorption, provides provides monosaccharides. The monosaccharides goes into glycolysis. It forms pyruvate. Pyruvate forms acetyl-CoA, and then it provides energy to the citric acid cycle and the electron transport chain. So acetyl-CoA is also contributed by beta oxidation of fatty acids. The fatty acids are being oxidized by beta oxidation, broken down, and then it provides loads and loads of energy through formation of acetyl-CoA. Similarly, proteins, after digestion absorption, they release free amino acids, enters into the metabolism. Amino acids are deaminated. The amino group is being released, and the ammonia is being excreted in the form of urea through urea cycle, whereas the carbon skeletons of the amino acids contribute to the formation of acetyl-CoA, and then again the acetyl-CoA goes into the TCA cycle, provides energy, and the electron transport chain. So acetyl-CoA is the common intermediate metabolite which is being synthesized from all the three major macromolecules, the lipids, polysaccharides, and proteins. Now, the major query here is that can we restrict carbohydrate from diet? Absolutely. Can we only live on fatty acids uh, and the proteins only? Is it really healthy? What do you think? Is it really healthy if we totally cut off carbohydrates from our diet? Just think about it. It's not healthy. If we totally completely restrict carbohydrate from diet, is not absolutely healthy, and it's really very injurious to the health, because many many tissues are only dependent on carbohydrate oxidation, only on carbohydrate oxidation for its energy needs. Let's take an example of such tissues. For example, the red blood cells, for example, the brain tissue is only dependent on glucose oxidation for its energy needs. However, when we totally restrict carbohydrate from our diet, what happens actually? The the body goes into a stressful condition in which the fatty acids and amino acids will be broken down to provide glucose, and the body will start synthesizing glucose through gluconeogenesis, that is for the formation of glucose from the non-carbohydrate precursor, so that it can provide the glucose to the tissues which are only dependent on glucose for its energy needs. So it will start gluconeogenesis. The amino acids will start being broken down and provide glucose. On the other hand, the fatty acids are being broken down to form acetyl-CoA, that will provide energy to the gluconeogenesis. And meanwhile, the fatty acid will also form ketone bodies, and there will be ketoacidosis. So there are various complications that can be caused by if we totally restrict carbohydrate from our diet. So it's really not healthy to completely restrict carbohydrate from our diet. Now the blood glucose regulation. Now, when we talk about the blood glucose regulation, it is being regulated by certain factors. There is a balance between factors that increases the blood glucose concentration, and there are factors that decreases the blood glucose concentration. So we have two factors which are actually um, helps in the regulation of blood glucose. Now, before we jump to the discussion how it is being regulated, there are what we need to understand the levels of blood glucose concentrations in different states. In the post-absorptive state, that after we have been approximately after 2 to 4 hours of taking a diet, uh, the blood glucose concentration is maintained between 80 milligrams to 100 milligrams per day. That is a normal blood glucose concentration, in which the food items, the diet is being digested and absorbed, and after 2 to 4 hours, the body is maintaining the blood glucose concentration between 80 milligrams to 100 milligrams. That is a normal blood glucose concentration. Now, when we take a carbohydrate-rich meal, just before after taking a carbohydrate-rich meal, our blood glucose concentration may rise to 120 to 130 milligrams per dl. The third condition we have is in starvation, that it may falls during starvation, approximately starvation for approximately to 14 to 16 hours or 12 hours. It may fall to 60 milligrams to 70 milligrams per dl. Now, what you need to remember here that the blood glucose concentration is being maintained within a very narrow limits. If you see in the post-absorptive state between 80 to 100, 120 to 130 in the carbohydrate after taking a carbohydrate-rich meal, and starvation between 60 to 70 milligrams. So the body is trying to maintain the blood glucose concentration in a very narrow range, and certain hormones and certain organs helps in the maintenance of blood glucose regulation. The two most important hormones which helps in the blood glucose regulation, they are insulin and glucagon, whereas other hormones are also there. For example, glucocorticoids or growth hormone, they also helps in the blood glucose regulation. For example, the glucocorticoids and growth hormone increases during starvation, and it causes gluconeogenesis and causes the breakdown of amino acids and provides more and more glucose. So the body here is trying to maintain the blood glucose concentration in a very narrow limits, and this only happens in a normal adult. Now, as the blood glucose concentration goes below 60 milligrams, we can say that the individual is having hypoglycemia. So if the blood glucose concentration decreases below 60 milligrams per dl, we can mark that individual as hypoglycemia, where a normal range is approximately, some books write is from 60 to 90, is basically 80 to 100. So it's all correct. You may find different ranges in different books. Now, as the blood glucose concentration below 60, there will be some signs and symptoms of hyperglycemia, that is neurological signs, that is hunger, because of the release of glucagon, epinephrine, cortisol, sweating, and trembling will be accompanied with the hypoglycemia. Then, if the blood glucose concentration goes below 40, this is severe hypoglycemia, and there will be signs and symptoms of lethargy, convulsions, and coma. If this hypoglycemia is not treated, it may lead to permanent brain damage, and death. So, in a normal individual, it is not possible that a blood glucose concentration goes below 60 milligrams per dl. This can only happen if someone is having if so having some long-standing conditions, uh, poor diet, or someone is diabetic who is on hypoglycemic drugs. For example, some individuals, some patients who are on insulin, if they skip their meal, the blood glucose concentration rapidly uh, goes down below 60 milligrams, going into hypoglycemic attack because they have not taken their meal and they are on insulin treatment. So in this condition, there may be higher chances of hypoglycemia. But this hypoglycemia is not possible in a normal adult. Factors affecting glucose concentration. So there are factors which helps in the addition in blood. For example, absorption from the GIT helps in increasing the blood glucose concentration. Hepatic glycogenolysis, that is breakdown of glycogen, which is the storage form of carbohydrates. It helps in increasing the blood glucose. Gluconeogenesis, that is the formation of new glucose from non-carbohydrate precursors like from lactate, pyruvate, and amino acids. Then glucose obtained by other sources uh, can increase the blood glucose, and renal reabsorption. There are other factors that increases the blood glucose concentration. Now this is maintained by factors that removes the glucose from the blood. The factors that removes the blood from that removes the glucose from blood, they are hepatic glycogenesis, that is the formation of glycogen, that is the storage of uh, glucose in the form of glycogen in the liver and muscles. Then glycogenesis in muscles as well. Lipogenesis, that is formation of lipids. Then oxidation of carbohydrates, that is oxidation of carbohydrates, that is the glycolysis in the TCA cycle. Then synthesis of non-essential amino acids can also remove glucose from blood, and other compounds, synthesis of other compounds like glycoproteins and glycolipids. So these are factors that removes the glucose from the blood. So we have two factors which maintains the blood glucose concentration. Now, the major organ that controls the blood glucose level. So my query here is that name that organ that control the blood glucose level, the major organ. However, various organs are involved, but just think about the major organ which helps in the control of the blood glucose level. Now, so the major organ that maintains the blood glucose concentration is liver. Liver is also known as a glucostat. Just like a thermostat of your air condition, the liver is a glucostat of your body that maintains the blood glucose concentration. Because it plays an important role, all the metabolic pathways related with carbohydrate metabolism is taking place within the hepatocytes, like glycogen breakdown, glycogen synthesis, then how it is being stored, how it is being released. All these major metabolisms are taking place in the liver. Now, just to sum up that how it plays an important role, how the liver plays an important role of glucostat, how it maintains the blood glucose concentration. We take a diet. The diet, after taking a diet in the gut, it is being digested and absorbed. The monosaccharide and the polysaccharides are being broken down into monosaccharides, and then it goes into the liver through the hepatic portal vein. It goes into the liver. The excess of carbohydrates are stored in the liver as glycogen, whereas the excess of uh, whereas the other carbohydrates goes into the periphery. The carbohydrates can synthesize amino acids, uh, and there is a pool of blood glucose which is being maintained within the narrow limit of 80 to 100 milligrams per dl. So this is a normal range. This is a normal range of blood glucose concentration in a normal healthy adult. It is ranges from 80 to 100 milligrams per dl. Now, this can be regulated by various factors. For example, this blood glucose can be taken up and consumed by muscles. It can be consumed by glands and other tissues. It can provide glucose to the brain, which is only dependent on glucose oxidation for its energy needs. And fat itself can utilize this glucose, and it can synthesize glycerol, and then it goes back to the liver, and the reversible reactions can occur. Whereas kidneys can also reabsorb glucose, or if the blood glucose concentration increases above 180 milligrams, it can be exceeded out in the urine. So urine blood glucose only present if it increases the renal threshold for glucose. What you need to remember here, that the renal threshold of glucose here is 180 milligrams per dl. If the blood glucose concentration increases above 180 milligrams per dl, the glucose will comes into the urine. Before 180 milligrams, all the glucose is being reabsorbed and conserved. So this is a very narrow limit which is being maintained. Now, liver is a glucostat that helps in maintaining the blood glucose concentration. When we have low blood glucose concentration, the liver glycogen will be broken down and provides glucose residues that can maintain the blood glucose. Whenever we have high blood glucose concentration, the liver will capture excess of glucose, and excess glucose will be forming a glycogen that will be present in the liver. So it will decrease the blood glucose concentration. Okay. Now, so we have two conditions of liver. It can become lipogenic when we have excess of glucose, and just after taking a carbohydrate-rich meal, the liver will capture more and more glucose, and because of the influence of the insulin, it will uh, it will synthesize triglyceride, it will synthesize glycogen, and there will be active glycolysis for the energy purpose. So it becomes lipogenic. It becomes lipogenic. It will form triglycerides, triglyceride that can be deposited in the fat tissue. So it becomes lipogenic. Whenever we have when the body goes into the starvation, when we have low blood glucose concentration, the liver will become glucogenic. That it will, instead of synthesizing triglycerides or forming glycogen, the liver will start providing glucose residues. The glycogen will be broken down sequentially and provide monosaccharides, glucose residues, because of the influence of glucagon, epinephrine, and cortisol. The glycogen will be degraded, and they will also be accompanied with gluconeogenesis. The non-essential amino acids will be broken down to form glucose. So in this way, in starvation, the liver will become glucogenic. So there are two states of liver. It can become lipogenic and it can become glucogenic. So in this way, the liver can maintain the blood glucose concentration. It is a glucostat of our body, and it plays an important role in maintaining of the blood glucose concentration. Now, the fate of the dietary carbohydrate. The fate of the dietary carbohydrate. A carbohydrate can provide ATP. It can be oxidized, degraded into lactate uh, through anaerobic glycolysis, and the major source of anaerobic glycolysis is metabolism, which has been going on in red blood cells and skeletal muscles during strenuous exercises. Then we have the carbohydrate can be stored in the form of glycogen, or it can form free fatty acids, or it can contribute to the formation of triglyceride formation. So the dietary carbohydrate can be have four fates. It can provide energy, it can form lactate, glycogen, and free fatty acids. Now, glucose synthesis during starvation. Now, it's very important as far as the starvation is concerned, and in this, it is being this discussion is basically, you can understand by using a plot between glucose oxidation on the y-axis and the time, the hours in on the x-axis. Now what we are going to do is we are going to plot a graph between the glucose which is being oxidized and on the y-axis, and the timing in hours, the 8 hours, 16 hours, 20 hours, 24 hours, and approximately after 1 day we have 2 days, 8 days, 16 days, that is the starvation stages. Now what happens when we take a carbohydrate rich meal in the fed state? When we take a carbohydrate rich meal, the blood glucose concentration rapidly increases, and most of the glucose which is being oxidized is basically coming from the glycolysis, and the blood glucose concentration will rapidly goes down. uh, in 4 to 6 hours it reaches the range of 80 to 100 milligrams per dl in a normal adult. Now, so the blood glucose is being oxidized through glycolysis, and the ingested glucose, which was present in your meal, it the provided the energy between 4 to 6 hours. Now, just after 4 to 6 hours, um, uh, just after taking a meal of 4 to 6 hours, we have another source of glucose, that is glycogenolysis. The blue line is actually representing the source of glucose. Instead of glucose, this glucose actually has come from the diet, whereas this glucose, after approximately 4 to 6 hours of taking a diet, the glycogenolysis, that is a breakdown of glycogen, will start, and it will reaches the peak of approximately 10 to 12 hours, and it will goes down, and it can be maintained even after 24 hours. That is, the glycogen content of a liver can maintain the blood glucose concentration from 4 to 6 hours to 24 hours, and it reaches a peak of 8 approximately at 8 to 10 hours. The glycogenolysis reaches a peak of 8 to 10 hours. So approximately at this time, the glycogenolysis is the major contribution for glucose oxidation, that they are providing the energy to the body. Now, um, at the same time, as the starvation stage starts in 2 days, 8 days, 16 days, so glycogenolysis cannot help in contributing or in providing the glucose. So what will happen? We have another pathway that helps in maintaining the blood glucose concentration, that is glycogenolysis. The glycogenolysis approximately starts at 8 hours. It reaches the peak approximately after 24 hours, that is 1 day or 2 days. And after 1 hour to after 24 hours, the glycogenolysis will reaches its peak, and it will provide the energy for glucose. It provides the glucose residues for glucose oxidation that can maintain the normal blood glucose concentration. So we have two ways that maintain the blood glucose concentration. We have the ingested glucose, which comes from the diet. We have glycogenolysis, and then we have gluconeogenesis. So in starvation, we have two pathways, which are glycogenolysis and gluconeogenesis, that maintains the blood glucose concentration. If you see in detail, it is, for example, in fasting, in Ramzan fasting, what happens? Our Ramzan days are approximately for 14 hours, 13 to 14 hours, approximately here, 13 to 14 hours. So a gluconeogenesis has already been started, and the glycogenolysis, after reaching its peak approximately 8 to 10 hours, it's going down. So both the pathways, they are being activated at the end of our fasting, approximately 14 to 16 hours. Both the pathways, glycogenolysis and glucogenesis, they are being activated and providing the glucose for glucose oxidation. Now, dietary fiber is the most important, is another important discussion of today's discussion. The dietary fiber, we have been talking about, many people have been talking about the dietary fiber and their importance in the diet. They are basically polysaccharide that cannot be digested by human enzymes, the GI tract. If you remember that um, the plant polysaccharides, they cannot be digested because we have a lack of the enzyme. So they are basically polysaccharides that cannot be digested. We have the cellulose. We have examples of dietary fiber. We have cellulose, hemicellulose, pectins, gums, and mucilages. So most of the dietary fiber is being contributed from the plant kingdom. So we have the major dietary fibers are in the form of cellulose, hemicellulose, pectin, gums, and mucilages. Uh, Once it is not being digested, it cannot provide energy. So the major purpose of dietary fiber is to provide the roughage to the feces, and the most important that it activates the uh, the gastric movements. Then we have a non-carbohydrate lignin. Lignin is also dietary fiber, is also being classified as the dietary fiber as a non-carbohydrate dietary fiber. So we can classify fibers into two types: the soluble and insoluble. The soluble, which are carbohydrate form, that is viscous, and the insoluble form, or non-fermentable, they comes from the non-carbohydrate form and the carbohydrate form. So the examples we have of soluble is pectin, gums, mucilages, and some hemicellulose. The major functions of soluble carbohydrate form fibers: they delay the stomach emptying, slow glucose absorption, and can lower the blood cholesterol level. So the food item that contains these soluble carbohydrate form, they they have generally low glycemic index, because they slows the glucose absorption and decreases the decreases the rate of increase of blood glucose after taking a diet. The examples we have in certain food items that contains these soluble carbohydrate forms, we have a citrus fruits, oranges, apples, bananas, oatmeals, carrot, barley, beans. So these are some of the food items that contain these soluble carbohydrate form fibers. The non-fermentable insoluble non-carbohydrate, we can have two types: carbohydrate and non-carbohydrate. The lignin is a non-carbohydrate form, whereas the cellulose and hemicellulose is a polysaccharide. The major function, it increases the fecal bulk, that it provides roughage to the feces, uh, and it decreases the intestinal transit time. The major sources for these insoluble fibers are the whole grains, wheat bran, all plants, wheat products, wheat, rye, rice, and vegetables. So most of the fibers are coming from the plant kingdom, whether they are soluble or insoluble. The fibers, chemically we have pectins, gums, mucilages, and hemicelluloses, whereas in the insoluble form we have lignin, cellulose, and other hemicelluloses types. And the major function is to delay the stomach emptying, low glucose absorption, and can lower the blood glucose cholesterol level by binding with the dietary cholesterol and decreases the absorption of the cholesterol. Whereas the insoluble functions are increases the fecal bulk, increases the feces roughage, and decreases the intestinal transit time. Now, if you take an example of a fruit, fruit contains carbohydrates. Yes, it contains monosaccharides, disaccharides, and polysaccharides, all type of carbohydrates, but along with the fibers. So along with the fibers, that decreases its absorption and it makes it healthy. Now, if you take an example of fibers that are present in an apple, if you take in a skin, the cellulose in the skin is a non-fermentable fiber, whereas the another is pectin, the viscous fiber is present in the soft part of the apple. So a fruit can contain both types of fibers, the soluble and insoluble fibers, that is cellulose, pectins can be present at the same time in a fruit. So what you need to remember here, that the fibers, the major contribution of fibers in our diet comes from the plant kingdom, that is from the fruits and vegetables. Fruits, vegetables, and cereals as well. Significance of fibers is disease prevention and treatment. It can prevent constipation, hemorrhoids, and appendicitis. It can prevent severe diseases like heart diseases from myocardial infarction by simply lowering the cholesterol level, because it binds with the free cholesterol which is present in the diet and decreases the absorption in the gut. Adult onset diabetes and glucose absorption. Adult onset diabetes can also be prevented by taking a significant amount of fibers in the diet, because it directly decreases the glucose absorption. Obesity, uh, obesity, yes, it can prevent obesity. Not only prevent, but also it can be treated by taking fibers in the diet. It decreases the satiety of an individual, and it gives when a diet contains a fiber, it gives a sense of fullness. So any diet that contains a fibers, it gives a sense of fullness to the individual. Now, the RD of carbohydrates is 130 grams, approximately 130 grams. That is the recommended dietary allowance of carbohydrate is 130 grams in normal adult individual who weighs around 70 kilogram, and it can be contributed from various food items. Let's suppose if we drink a cola, it can contribute approximately 30% of the carbohydrate. M&M's 23%, banana can contribute 22%, yogurt can contribute 15%, then it goes down to the carrot approximately 6%, peanuts 5%. So the most of the proportion is coming from the food items that contain refined sugars or free sugars, and it takes the major proportion. It can take a major proportion of our diet, approximately 30% or 23%. Now, the glycemic index. The glycemic index is basically a ratio. Uh, is basically calculated by a glucose response to test food divided by the glucose response to the standard food by 100. So it's basically a ratio. What happens here? We we can test the glycemic index of any food item. So we can take a food item of your choice and take and observe its response after taking that specific food item. Let's suppose we take a food item. For example, let's suppose we take what we should take. We take hmm, we take a cereal. Okay, oatmeal. Okay, so we take an oatmeal. So and we will observe the glucose response and how much blood glucose will increase. We divide that response, that how much glucose is being increased, by the glucose response to the standard food. Now, that standard food will contain approximately 50 grams of carbohydrates, and standard food is most of the time we take white bread as a standard food, and then we will compare the response at how much glucose is being raised by the oatmeal and how much glucose is being raised by this white bread that contains 50 grams of carbohydrates. That is being standardized that this food item will contain 550 grams of carbohydrates. Now, a glucose response is basically is and then we multiply with 100. Now, this is a calculation which is easily being done, but the most appropriate way of finding out the glycemic index is to plot a graph and then we take a ratio. So a glucose response is area under the curve of the blood glucose measurements taken from 3 hours after the meal. But at this time, what you need to remember here that the glycemic index is basically a ratio between a glucose response to a test food, any food item, divided by a standardized food that contains 50 grams of carbohydrates multiplied by 100. That gives you the glycemic index, and that tells you that how rapidly a food item can increase the blood glucose concentration. So basically it's a ratio between the standardized food and the food item of your choice, and it will tell you that how rapidly it increases the blood glucose concentration. So ratio of blood glucose response to a given food compared to a standardized food. A standardized food can be free glucose or a white bread containing 50 grams of glucose. Now, a glycemic index ranges as it's a ratio that is we multiply with 100. It ranges from 0 to 100. It is influenced by the starch structure, how how much complex carbohydrates are present, what is the fiber content of that food item, uh, is the food item is a processed food item or it's a raw food item, how is a physical structure, what is its physical structure, and for example a physical structure, for example, if we compare fruit, let's take an example of a fruit, for example eating an orange as a fruit and drinking an orange juice. That's a major difference. And eating an orange as a fruit have a low it's usually have a low glycemic index as compared of drinking an orange juice that will be containing the higher glycemic index. So other macronutrients in the meal also plays an important role on influencing its glycemic index, such as fat content. If you have more fat content, it will decrease its absorption and it will decrease its glycemic index as well. So what is the glycemic index? Is basically a ratio of blood glucose response to a given food compared to a standardized food. Is basically we observe that a food item how rapidly a food item can increase a blood glucose concentration as compared to the standardized food. It ranges from 0 to 100, and the food items they lie in this category. The categories we have is low glycemic index foods, intermediate glycemic index foods, and high glycemic index foods. The low glycemic index foods are normally below 55, intermediate ranges from 55 to 70, and high glycemic foods are more than 70 glycemic index. Now, okay, sweet items, mithai, bakery items, colas, croissants, white bread, all the processed foods, uh, jellies, pizza, white bread, colas, sodas, they all contain processed foods in which there is readily availability of free glucose or free sugar. They all are comes under the category of high glycemic index. The food items we can have is baked potato, French fries, rice cakes, bagels, refined cereal products, sugar sweetened beverages, jelly beans, candy bars, juices, of basmati rice, they all comes into the category of high glycemic index, and it should not be taken by diabetics, as well as they can the normal individuals should also avoid these food items that come into the category of high glycemic index foods. Now, um, sweet potato, corns, and multigrain breads or brown breads, they all come under the category of medium glycemic index, that is from 56 to 69. Orange juice, popcorn, corn, sweet potato, brown white rice, oatmeal, whole grain breads, pasta, no sugar added juices, they all come in the category of the medium glycemic index foods. Then we have a category, for example, raw fruits, raw vegetables, and we have a dairy products, which comes in the category of low glycemic index. That is, they are high fiber diets. They contain high fibers like fruits and vegetables like apple, pear, green beans, and apricots. Then we have milk, yogurt, which are dairy products. Then we have legumes, and then we have chickpeas, beans, lentils, kidney beans. They all come in the category of the low glycemic index foods, and they are really helpful healthy for a healthy lifestyle. Now, another concept along with the glycemic index, we have glycemic load. It's very much similar to the glycemic index, but it's a little bit different. The glycemic load is basically a product of glycemic index and the amount of a carbohydrate consumed divided by the 100. So we take a glycemic index of a specific food and we multiply it with the how much carbohydrate is actually present in that food item, and then we divide it by 100. What we get is a glycemic load. Now you will observe a difference between here you will observe a difference between a glycemic index and a glycemic load. A glycemic load, a carbohydrate content of that food item, the glycemic index of that specific food item divided by 100, what we get is a glycemic load. Now, again, we have categories of low glycemic index. For example, low glycemic load below 15, intermediate from 15 to 20, and high glycemic load from more than 20. Now, if we take an example, for example, vegetables, the glycemic index is 49. Carrot, let's take an example of a boiled carrot. We have a 49 glycemic index and its glycemic load approximately 8, because its carbohydrate content is really low as compared to the baked potato. Potato, again, the grams are same. Its glycemic index is really high. Its carbohydrate grams are really high as compared to the carrot, and its glycemic load is also very high. So it's not healthy. This tells you that a baked potato can rapidly increase the blood glucose concentration, and it can lead to certain comorbidities, like it can lead to diabetes mellitus, increased chances of myocardial infarction, increased blood cholesterol level, and various diseases. Then we have dairy food items. Then we have fruits, as you can see here. If we compare apple with banana or orange, the glycemic index is 38. The glycemic load of apple is 8, whereas banana, the glycemic index 55, and the glycemic load is 16. So if we compare apple with banana, the banana is having high glycemic index and high glycemic load. Beverages, orange juice, they all have Gatorade, Coca-Cola 16 glycemic load. So the glycemic load is much higher. The orange juice, as you can see here, the glycemic index is 46. If you compare with the orange itself, the orange, the glycemic index is 44, whereas the orange juice glycemic index 46, but its glycemic load is much higher as compared to the orange itself, that is 13. Snacks, potato chips, glycemic load is 8, whereas jelly beans is very much higher, that is 21. Wafers, snacks, much higher glycemic load. So these are not really healthy food items that can increase the blood glucose concentration very rapidly. Now, similarly, we can list the fruit items with a glycemic index and a glycemic load. So I'm just trying to give you a sense of food items that have different glycemic index and different glycemic loads. So when you will go to your practices, you can uh, counsel your patients as far as these nutrition is concerned, at which food items you should be taking, which food items you should not be taking. Okay, let's take an example of strawberries here. Strawberries glycemic index approximately 40, low glycemic index, whereas glycemic load is only 1. That is, it's really healthy, not increasing the blood glucose concentration very rapidly. If you compare it with dates, the glycemic index, the glycemic load is 77, much higher, because it contains more and high concentration of glucose. Its glycemic index is 103. Bananas 52 glycemic index and the glycemic load is 12, so it's more acceptable. Bananas are more acceptable. Okay, now we have, if we plot, if we make a 2 by 2 chart between the glycemic index and glycemic load, and we can categorize certain food items that have high glycemic index but low glycemic load. For example, popcorns, watermelons, they have high glycemic index but low glycemic load. So it's not um, uh, it's really healthy to take these food items. That is whole wheat flour. Okay, so they have high glycemic index but very low glucose load. Whereas on the other hand, we have certain food items that may have low glycemic index but high glycemic load. For example, macaronis, spaghetti, again they have high glycemic load, and they can they can have a bad effect. They can The body is taking more glucose content in the form of these food items like macaroni, spaghetti, and they are not really healthy. Okay, so we have reached our end of this discussion. The reference for these books are Lippincott. Then we have Harper, Nutrition, Digestion, Absorption, chapter 43, and then we have the Advanced Nutrition and Human Metabolism, and the Groove and Copper 2000. So now, any queries? Please start Q&A session. Student, if you are listening, please, if you have any queries, write in your chat box. Ji says, so when selecting a diet, should we go for glycemic index? Okay. Now, we have to take care of both glycemic index and the glycemic load as well. As a nutritionist, you should be observing both the glycemic index and the glycemic load both at the same time. Okay. Healthy carbs are those which have a high glycemic. I'm so sorry. Minha Murtasa. Healthy carbs are those which have low glycemic index, and low glycemic load. But there are uh, certain food items that have high glycemic index and low glycemic load. These are only basically these are some of the some food items. They are actually particularly with the glycemic and glycemic load. Healthy food items are those, as far as the blood glucose concentration is concerned, are those that have low glycemic index and low glycemic load. But we have certain odds that have, for example, watermelon is having a high glycemic index but low glycemic load. So you can take those food items like watermelon. You can take watermelon instead of having high glycemic index. It do not contains high amounts of carbohydrate. So if someone asks you that uh, can a patient who is suffering from diabetes, can he eat watermelon? Your answer should be is that yes, but in a moderate amount, in a low amount. Okay, sir, though the liver is carrying out all the process of glucose metabolism, but it is dependent on pancreas for how much? Yes, correct. So why pancreas is not considered the master control of blood glucose? Okay, master control of blood glucose. Okay, it is basically, yes, it's an endocrine gland, it's an exocrine gland. The endocrine part secretes the insulin and glucagon, but it controls the metabolisms, the same metabolisms which are taking place in the liver, in the hepatocytes. The insulin is acting on the metabolic pathways, the glucagon is acting on the same metabolic pathways which are taking place in the hepatocytes. Does excessive sweating, okay, Nazia Parvez, thank you for asking this. Does excessive sweating lower blood glucose levels? It's actually the other way around. It's does excessive sweating do not decrease the blood glucose concentration, but whenever we have lower blood glucose levels, the sign and symptoms can be excessive sweating, diaphoresis. So it's really tricky. Excessive sweating itself do not decreases the blood glucose concentration, but it this sign and symptom, excessive sweating, diaphoresis, can be accompanied during hypoglycemia. Okay, any queries? Ji, please, students. Amir Rab. Amir Rab, what you have shared here? Biochem, dietary carbohydrate. What this PDF document is related to? Can you please elaborate? Can you please tell me? Can hypoglycemia cause postural hypotension? No, not at all. Arisha. Can hypoglycemia cause? No. Not a postural hypotension, but again, postural hypotension is a different thing. Postural hypotension itself is a different thing. Hypoglycemia can cause certain signs and symptoms of confusion, coma. So it's really different from postural hypotension. Ji, students. I think we have exceeded our time. It's 10:35. Hello, Asif bhai.
जी सर
Ji, we have already exceeded our time. It's 10:35. So can we end our presentation of?
ठीक है सर मैं एंड कर
Okay, Ji. Thank you, students, for listening.